So to introduce myself, my name is Stefany Allaire. I'm the, designer of the Foenix. Well, there's more than one product now. So I've been designing, new retro computers for the last 3 years. My background is I'm a hardware design engineer. I've been doing that for 30 years. Throughout many, I've worked for so many different companies. I've started my own companies many times, which led me ultimately to do a lot of different things, mechanical design, FPGA design. I used to do schematic capture and board design and stuff like this. But overall, I think after all these years, I think I gather a lot of experience into designing products overall. And since I started designing the Foenix product line, I went through this, at first it was for fun. It was really a hobby. The whole thing started with the whole David Murray, hey, I'd like to, somebody to design my own dream computer. And then I'll talk more about the whole story. But bottom line, I kind of came up to there was some ups and downs between the moment I started and today. And too many times I got a lot of, remarks from people. And I understand that some people just don't understand the concept of what's involved to design these things. And I thought that this year into these different shows, I would present the processes of actually creating a product from scratch and to bring it to market. It's still within the world of retro computing. I'm going to use the upcoming C256 Gen X as a use case, although it's been designed to a certain point. It's not finished. The design will be, starting all over. Well, not over again, but it will be restarting, I would say, in October, because I've been working on other stuff, and I will be talking about this. So I'm going to give you an overall of what's going on, everything that's been I've designed, and with the community that has been created over those 3 years. What's the different products, the one that have been that existed before, the one that are existing now, the one that will be existing soon. I'll do a little bit of an evangelization. I will talk to you about the reason why I'm doing this, because I'm doing something kind of fringy and on the side, and I guess you need to be a little bit crazy to do this. And then I'll basically go to the concept and finish what it takes really to go from, yay, I have an idea, to, hey, I can ship something, and all the pain and suffering that ones will inflict themselves to actually do that, and the hell loop you're going to get yourself in, and is it worth it? All this fun stuff. And at the end, after an hour, I'll stop. Hopefully I will have gone through everything, and I will do the unveiling of the A2560K, which is I would say the flagship, because that's the most expensive of all the computer I've been creating. It's a 68040 new retro computer with a keyboard integrated, and I've been talking about it for a while, and this is one of the products that I talked about but I never showed, and I kept it close to the chest. So today is the day that I will finally show it. It exists. It's not even a CGI thing. It's really real, and it will be shipping in 3 to 4 weeks from now, and we'll talk more about it later. So I think a lot of people are waiting for this, so hopefully you can hang on. So let's get down to brass tacks. So I'll do this one, fast. I don't know if you can see everything. I'll look at my OBS to see if you see everything. I think it's pretty. Yeah, I'll try to increase it, and I will show you a part and move it along. Okay, so at the top left corner, we have the first one I designed, the C256 Foenix. That was the original one based on the 65816. That was in April 2018, although this product I have done during the summer following the April. April was the date that David Murray came up with his thing. I'm not going to go back there because I've talked about this like 20 times before. There's many videos about it. After coming back from the Portland Retro show in 2018, talking to some friends. I kind of revisit things. I got influenced a lot, and I think I should have not been influenced so much. And I came up with the B2 version, which was the first version I released to 5 different people, which was mainly the people involved in the alpha group that most of them are still part of the community now. It was still based on the 816, but it was really the first where I started designing the VK chip, which is the graphic chipset for the system. And then, but there was some changes needed. And then I'm a pleaser by nature. So, you know, when you're a designer and you're a pleaser, this is 2 things that usually don't go very well together. So I decided to try to get more people involved, and I stuffed it with a lot of sound chips in there. So you have like the OPL3, OPN2, OPM, and I called it the FMX, which was the Phoenix Music Extension. So came the C4A, C4B, although in between the B2 and C4, there was a lot of iteration. It was in 2019, and it's been a tough summer because I went through a lot of problems and everything. The 816 is a great processor. I love to program it, but my God, it's a bit tricky to set it up in hardware if you run it at 14 megahertz. So, but I sold 70 units during 2019 and 2020. But the unit was very difficult to manufacture, took a long time to put together, and was relatively cheap for what it was. But there was a process in between the Phoenix U, which was a low-cost version. I was trying to bring more people in, and basically I realized that it was not really about the price. The problem was not really the price as much as the offering, that the value offering that these platform could offer. And you know, and I think this is one of those moments where I realized that everybody has their group, their processor they love, and the 6502s is very popular. There's a big group that has adopted, but the 816 is still very fringy, even if it was used in the Apple IIgs and SNES and all these platforms. They're very unique and very specific. So I kind of painted myself in the corner with this processor. And again, it's still a very good processor, but it was very, unique, and people are kind of scared to get on it, to get and start programming with it. I don't know why, but it's very fun. When you get on it, it's really fun. So at the end of 2020, I lost my job. So I was like, for many months, I was wondering, okay, am I going to keep going with this? And I started, pretty much working full time. And then after doing a small survey within the community, I kind of realized, okay, I need to expand my offering into different processors. And I came up with this concept of having the same platform, but with different processors. And that became the Gen X. But in between, the idea was, okay, I need to kind of get to know the 68,000. And what happened is that I decided to promote and start talking about the Gen X. And the Gen X is basically a dual CPU system. So you can boot it in 816, or you can boot it in 68,000, 6830. It's a modular. The second CPU is modular. So you could put all these different processor. You pick one, you install it, and you boot with it. Again, always the same hardware, might be mapped at different place in the memory, but still you access it the same way. But before I could do the Gen X, I decided to develop myself a board, a single board, because the Gen X is very modular by default. There's multiple assembly in the board and the product, and that made the design or the development more complicated, that it could have brought more expenses. So the idea was, okay, usually when you're doing design, you try to integrate everything on one board, and it becomes your development board, and then you expand and you can separate it later because you know it works. So what I did was to create the A2560K board, which I will show you later. But before, and that's the first board I designed immediately after showing my product presentation of the C256 Gen X that was going to come. And then out of this, I started doing the design with it 68,000, the SEC 2000, 20 megahertz. And from that, I kind of merged the C256U into the A2560U. So all the Motorola 32-bit, 16-bit, 32 bits are the A2560. And then basically I respawned the C256 Foenix U, which is a low-cost entry-level 65816 product, and I put a different processor. And since I did the translation for the 68,000 with the rest of the hardware, I decided to bring in the same kind of entry level. And so far, it's been a great idea because there's definitely a lot of interest into it. But the center part, the heart of what the Foenix U is and what the Gen X will be is the board of the A2560K. Again, that was, and the A2560K is a one CPU system, although I did start with the 68,000. It's ultimately going to be only the 68040 V at 25 megahertz and possibly 40 megahertz, although the chip is definitely more expensive. And from that, the Gen X will come. And out of this, I came up with the 2560X, which is basically a Gen X without the 65816 subsystem. So it's back to be a 32-bit system, but modular still. So you can still choose the processor you want in the system, but there's no 816 in it. So it's a bit cheaper. All right, so this is the story. So this is till the U's are shipping this month. The A2560K will end probably ship early November, end of October, early November, probably more early November. And the Gen X should ship probably in December, in mid-December and so on. After that, we'll see, but so on, that's what's going on. So I just explained what these are really what's going on, the three new things. So the idea was really, I cannot support a very big production flow right now. So basically the idea is really to focus on coming up with products that are niche. So because early on I was in this realm of 8-bit computers, and then there's David with the X16, there's the Mega 65 people. So right now, Mega 65, I've sold like 400 units. They were prepared. They had a lot more money at their disposal to do everything they did. The fact that you have an entry level into the C64 probably helped a lot. So my strategy from 2020, early 2021 was to go away from that world. In reality, I'm going to become, or the idea was to become like the SGIs and Apple of the new retro computer world. So really focus on the high-end stuff, maybe low volume, very low volume, but still really tackle these people that are more interested to go with bigger machine and, instantiate, more fancy stuff and everything. So moving on. Why am I, I'm going to take 5 minutes on this and basically is like why I'm getting to do this. Okay. So yes, sir. So the idea is, all right. Okay. You're welcome. Okay. So ultimately the idea is that when I got into retro computing in 2018, I think there's a lot of people that came during this time. And I thought that, there's just so much you can do when you're going back into playing with your old computers. And I think there was something missing from the experience. I think nostalgia is really what people bring, that this is the key factor that brings people back in. But most people have been mainly updating their old computer back to 2021, 2018 and on technology, which again, it's like you want to pip in your Amiga, it's great, but then it's still an Amiga. And I think part of the whole, nostalgia factor is, and that's the thing I think is missing, and that's what I'm trying to push for, is the fact that part of the retro time was the fact that when we were younger, we got a Commodore 64 or any other computer of that kind. That was the time we were trying to figure it out, to learn it, to sit down, try to program it. I think there was a lot of reward into the work of trying to understand it. And then we got games and we got into hacking. We've learned a lot. We created a full generation of people that got involved into programming and hardware design. I'm one of these people. And what I'm trying to do is really to bring this back. That's part of nostalgia that is missing, I think, in the overall retro community. I mean, it's quite clear that everybody has their gang. It's very segregated, but there's always a portion of all these people involved. I mean, people are creating C64 games. So some of these people were not game programmers before. They had to learn, get back to it. So this is basically the philosophy behind all the computers I've been creating, to really bring back the people to go back to discover. And it involves work. And that's why it's so difficult for me to get the whole idea to go across, because you need to get off your ass, sit down, and to learn a new machine. And we got lazy over time. You know, we know everything about everything, and, you know, Linux, Windows, we know all about these things, and we don't think anymore. We don't, you know, get ourselves to learn new things and try new things. So this is really the overall idea behind what I'm doing. And it's a tough job, because, you know, people are lazy, and I'm lazy as well. You know, I can include myself in this. But I think a lot of people got involved in it and start doing things can be really rewarding, and that's nostalgic and rewarding. And this is a great feeling, and that's what I'm selling. But it's very virtual in terms of ideas. So it's not like I'm selling you an iPhone 13 or something. So it's like a long period of foreplay and sex and everything. It's not like a 2-minute thing on the side of the table, right? So again, so this is why I'm doing it. I believe in the idea of, you know, if you actually sit down and learn it, there's a lot of reward. And early on, I think it's more interesting because there's so much to bring to the table for others to use. And, you know, if you're part of the Mavericks early on, you can leave a mark. And I believe that there's still a way to make this thing bigger, but people need to believe in it. And that's the difficult part I struggle with. But, you know, I manage with what I have, and, you know, it's going okay. I'm not going to complain. I mean, it could be a lot worse. So at this point, I'm going to go into the process of starting to design a product. Okay. So basically, first part of, if you want to get involved in designing one of those products is, okay, you have a good idea. First thing first, are you insane? Okay. This is the first thing you have to ask yourself, because when you get yourself into designing something like this, you're going to get caught into a lot of things that you don't think about at the beginning. So first thing first, are you insane? If you're not, do you have a lot of time to give away to it? A lot of money to spend for it? I mean, I guess these are questions that most people don't ask themselves when they get in a hobby. But when you're just doing onesies and twosies for your friends, it's not a big deal. But if you want to start selling stuff to others, and you're part of a specific community, then you might be facing some critique, and you kind of need to know what you're doing at the time to really justify the means to design what you want to design. So personally, I got for fun into the whole thing, and then basically became more serious than I thought, and then I got caught in it. But still, I enjoyed the process. I've done it many times. So do you have a lot of times? Do you have a lot of money? Do you have all your head? Can you see yourself doing that for many years? And if you're going to sell it, are you ready to deal with the trolls and all the critique and everything? And I think most of the time we get in these processes and we don't really ask ourselves these questions. But hey, I'm telling you today, these are questions that one should ask themselves. I don't know if you're seeing this clearly. I can make it bigger if you want. Okay. So great. So when David came up with his ideas at the beginning in April 2018, I took a while to think about it. I said, okay, how I would go about this. So I created this first block diagram, and it was very fancy. It was very beautiful. So if you remember the first product I showed you, that was basically what it was supposed to be. And I pretty much fulfilled that requirements, although I did stuff it with a lot of stuff that was not supposed to be there, And then 3 years after, because the idea was, and I think it's a great idea from the beginning, to really establish exactly what you want to do. So you create a block diagram of what you want to do, which I think it's like any creative endeavors, you need to make a plan somehow. So 3 years later, this is my block diagram for the A2560K, which a lot simpler. You can tell that I didn't spend so much time because my enthusiasm for the whole process got eroded over time. I was like, okay, I just need to put those blocks down and to figure things out. But still, the interest, it's still very important to do the process, and I did that. So I thought I crossed that check on the checklist to let's create a plan. And basically after that, I got or usually you get yourself into the design phase. And usually with electronics products, we start doing schematic, boards, board layout. But for me, it was like, okay, do I have the right tools? I think one needs to get the right tools to start designing products that one would want to sell to others. I mean, you can get free tools, but those free tools are free and they're not as stuffed. I mean, it's not like Blender that became over time super good. I'm not saying that the free tools are bad, but at some point when you deploy these design and you want to start making more complicated stuff, it might be limiting. So for me, I did start with the cheap, well, not cheap, but on inexpensive tools. And in the middle of the design process, I switched and I created more problems. So make sure you choose your tools right. The mechanical tools, the schematic tools. I ended up paying for Altium because now Altium designers, you can pay per month, although it's still expensive, but I think it's worth it. Yeah, so basically I start creating. So first thing first, you create a schematic design. I would say that anybody who wants to design products, please use the available website that offers free symbols and parts and everything that you can import in your design. So don't reinvent the wheel. I would say that if you're going to use those services, SnappyDA, SumAxis, all these guys, they're great, but assumption is the mother of all fuck ups. I'm going to repeat that many times today. Just don't trust them. You have to verify them. One would think that it might be good, but the more recent one seems to be better, but the old ones might be like old parts might be not as good. So be careful. Take your time when you're doing your design, revise your design. Usually you put it on the back burner and then a few days later you come back. And I'm saying it and I'm trying to follow my own rules. Sometimes I don't, and I get punished because there's a problem with the board later. Use any reference design that you can find. It's really important. If you're designing with FPGAs, some rules for you guys if you want to do it. If you want to start doing the FPGAs, the rules are decoupling, super important, and a lot of different values to capture all the noise on different frequencies. Always make sure that your clocks are in and out are connected on the right pin because they're always reserved and they're specific. And make sure that your JTAGs, connectivity and programming, programming pins are also very well connected properly, because if any of these things are wrong or missing, it's not going to work and you're going to trash it. And this is probably the most important thing. And when you receive your board, you build it. This is probably the first thing you want to test. Yeah, it does power up. Then you test the JTAG right away, because if you cannot talk to the FPGA, there's nothing you can do. Also, it's a good idea to fan out all the pins on your BGAs, just in case. I've done that many times, and I got FUCK every time. So make sure to fan out everything, even if it's not very convenient for the PCB layout. But overall, I think it's a great strategy to, always, to implement everything. So moving on to basically the process that I went through many, many times during my career is always, okay, you start with a schematic, you make a plan, you start with your schematic, and then you start placing your parts. But nowadays you have the possibility of doing mechanical design. So I'm going to show you the other part. So basically this is what I did. So I did a preliminary placement. Usually you place your connectors, you establish the size of your board. I use an ITX, mini ITX for the Gen X, which is standard. That's the first time I'm going to design something that uses standard size to allow people to use a standard enclosure. Although like I said early on, there's many assembly in the board. So I don't know how people would go about installing the other assemblies in the board, in the enclosure they would choose. But there's definitely a possibility there for people to do this. So people complain, I try to listen to them. In that case, I usually try to do custom design, but custom design has its own set of problems as well. You know, you have to, 3D print everything, because 3D print is the only way for us, but I'll come back to this. So like I was saying, you basically, I went, or you would normally do an early placement, and you go fetch all these 3D components as well, 3D models for all the components. You can find pretty much all of them nowadays. Please do that. Very important to make sure everything fits. And you export it, and then you start your 3D, enclosure design. And that's what I did. I created the board, and then I start from the bottom and I create everything up. I had an idea. I wanted to recreate the good old cube from Next, or the concept of SGI, which I'm very inspired from, because like I said, I wanted to leave the world of the 8-bit computer to a certain degree, at least for the Gen X. So I think it was a great way to go about it. So as you saw, this is what I came up with. Yeah, but it's still a work in progress. When I'm going to go back to it, I need to finish it and then start getting quotes and everything. So that's also part of the process of getting this design. So one of the things you need to face when you're doing small batches is the fact, okay, you have an enclosure, it's a custom enclosure. How are you going to go about it? This is really, you have to go and see, okay, what material are you going to use? Is it 3D printed? And then you need to make it fit. So you need to print it and, make it better, go back, choose the PLA, what kind, and is it, what kind of setup you need to do. And you go back. So that's what I wrote down. So 10, you print an enclosure. 20, is it doing the job? No, go back to 10 and do it again and again and again till it fits. So when you're close to what you want, you just lock it down, and then you go back to you start doing your PCB design. So you ultimately end up your PCB layout, you know that your connector is going to fit, and that's what I did. And in the process of creating this, you go through the same processes as if you want to create something. Don't assume anything. Assumption is the mother of all fuck ups. So use all the 3D models, the footprints and everything, check everything. And usually if you deal with PCB manufacturers, try to go with less layers, try to use finer details on the PC board as opposed to have many more layers, because it's a lot less expensive. There's way more manufacturers ready to take on your orders in China, for example, if you have only 6 layers as opposed to 8, because at that point, the really cheap shops don't do 8 layers. You have to go to the fancier, and it starts to be more expensive. I know that, GLC PCB, for example, can do very small lines and spaces on the top and bottoms of the PCBs, not the internal layers, but it does help a lot. In my case, for example, I'm using a 780 pin BGA for the Gen X. So in order to fan out all these pins, I need to use these 4/4 tau separation and everything. So these are the specificities of creating the board themselves. So for anybody who's been seasoned and doing that easy peasy, that's really the easy part if you think about it. Then comes the fancy stuff and the more problematic stuff. Because the world we're living in right now, as you know, is full of pitfalls and problems, and it's not as easy it was like even 2 years ago to get parts. And first of all, if you're doing small batches, you're caught dealing with DigiKeys and Mausers and sometimes arrows, although arrows are definitely better in terms of pricing. But if you want to deal with DigiKey and Mauser, you need to have a lot of lubricant and you have to bend over, because these guys are charging you an arm and a leg, and they really are FUs. You know what I mean? So at some point you need to go east to go find your stuff, and then you have to deal with the arrogance of some of those vendors in AliExpress, Alibaba. Although my experience has been that if you find yourself a good Alibaba supplier, you're good to go, and you'll have pretty much all the time good quality parts. The problem is that most suppliers deal with the same suppliers. They have like main suppliers of certain parts, and when you're dealing with old parts, you can have, you know, shady stuff going on. But it's a hit and miss. For me, what I decide to do over time is like to order the same thing at different places. So if I get a batch of shitty stuff, then I can rely on the other batch I got. Certain parts are more difficult to find, but you can find pretty much everything you want. AliExpress is the same thing, although AliExpress is more like the garbage place. But, you know, if you want parts, you'll find good parts. Most of the time I have good parts. I think it's really when you're not getting the thing you ordered, or if you don't get parts that are half working, you need to expect that. So this is where you start dealing with shitty suppliers that don't want to give you back your money. They don't want to ship your stuff. So I think the idea of not putting all your eggs in the same basket when dealing with China is the good strategy. You don't want to buy a batch of 500 pieces on one place. This is ridiculous. You're going to get burned with this. Don't do this. So after you designed it, you have your PCB stuff, you buying your parts, you're starting to build your thing. Also, something I maybe I wrote on the slide or not, it's really the idea that buying your parts beforehand, even if you have to pay more, is always a good idea, because you can test the footprint of your parts to see if they fit. It's a great thing to do for the one that, you know, don't do that often. There's a lot of mistakes created from the fact that we assume again that the package will be a certain way, and then we end up like, oh no, it's not exactly what I thought. So you design the boards, you have your Gerber file, you're ready for fabrication. Obviously you want to go to China, it's cheap. Rule of thumb, if you're dealing with PCB manufacturers, use the one that are not advertising as much as the others, because the one that advertise a lot, usually because they have something to hide, I don't know. I did deal with the one that was advertising a lot, and they did some crap, and I never went back. So I don't know why people are promoting them so much. I don't want to say their names, but I'm sure people will figure it out. I deal with GLC PCB, and they're doing great most of the time. It's China, after all. I mean, I love Chinese people. It's just that sometimes they're big and they're producing a lot, and sometimes there's a lot of overlooking on stuff, but that's okay. I think it's something you need to expect when you're dealing with these people, and so cheap. Anybody who has been designed before knows that 10 years ago, you would pay like $3,000, $4,000, $5,000 to get a batch of 6 layers. So today is like, okay, I'm not going to complain. I'm just going to get it done again somewhere else. I don't know. So this is also part of the whole process of getting your PCB. So designing, it's one part. Purchasing is another part, and dealing with all these shenanigans. Fabrication, another part of shenanigans. If you need to create your BOM, I would suggest that people get some bare board first and build them by hand first. I think this is really part of the whole process of completing the cycle of design. I think it's really a great time, and you get to build your own stuff, at least for first prototype. So get your tweezers, get your parts, you know, Friday afternoon, Friday night, and you just put in your stuff. I would also suggest that you unpack your stuff before and you put them on a plate or something, so it's a lot faster. But I don't want to get too much into this, but overall, I think going into the early fabrication is important. So after that, so far I've been creating all these things and came up with boards, and okay, so I'm trying to align this more properly. Hold on. Okay, so you got your boards, you got your parts, you sat down one Friday at night and you put it together. You said your wife, hey, go have some food somewhere. I'm going to build this baby. And then you need to fire it up. So people are always like very anxious to put power on. For one, I'm a crazy person, so I usually don't bother. I just plug it in and say, hey, either I'm going to see a show of flames and smoke, or there will be nothing. And most of the time it's nothing. You know, after 30 years, one would expect that you'll have no smoke. And usually I don't have any problem with that. Some people wait a few days and they're like doing any tests and verifying everything. It's just crazy. So usually I go for it. and worst case, most of the time anyway, if you're using switching power supplies and regulators, they usually have like short circuit protection, so you can really feel the heat coming out really quickly, and you can fix it, and you're on the track to get it to work very quickly. Then the first thing I do when there's an FPGA, and all my designs have FPGA, is to literally put the power on, verify all the rails. And when it's all great, then I just check the damn FPGA. I need to see if the clocks are there, but the JTAG is the ultimate thing. And like I said, if it's not good, you didn't fan out your stuff and you're like, then it's go back to square one, and you need to go fix it and get another batch and wait 2-3 weeks and so on and so forth. So that is without having any other problems afterward. But that's the process. So if you manage to all that and you didn't throw your stuff to the garbage, I think everything is fine. So you're still in one piece mentally, everything is going good. So then you move on to the debug phase where you're going through the debugging and find the problems, and you'll probably go back to let me center all this. So you designed it, you put it together, you put the power on, you got it to talk to the FPGA, you're starting to do your design, and it starts to work. And then you go back to another revision, because I know very little people that do stuff the first time. So you have to go back, do it again. So that's a lot of time and a lot of energy, and you didn't show it to anybody at that point. So is your FPGA functional? Do you feel good about yourself? You're starting to see the light at the end of the tunnel. That's really a great feeling. You're probably halfway through your nightmarish situation, because now you didn't get even close to dealing with the external world. But you start talking about it. Say, hey, I have something working. This is great. And in my case, back in 2018, I was contacted by the people from SnapEDA, and my strategy was just to design this computer in my basement, although I was not in the basement, but in the shadows. And one day I would come, hey, da-da-da, there you go, it's done. But the lady, the CEO, Natasha at the SnapEDA, it happens that I was the 100,000 subscriber to her site to get parts. And she asked me if I want to do an interview. And little did I know that she had a lot of, reach outside, and I got a lot of attention really quickly, and I was not even close to be ready, which influenced a lot my decision in the first prototypes. Also made me very miserable, but because I was trying to please everybody about what I was doing. So I've learned a couple of lessons with this. But again, when you're starting to put yourself out there, you start getting critique. People want this, people want that. Some people, there's really insane stuff, and you need to, swim through all this stuff and make a decision. And then you need to be adamant about your vision, but you also want to please, because if you want to sell it, you need to kind of give what people want. So it's a tough call at some point. And at that point, if you get connected or get known, then the trolls are coming out and they start bugging you. And it's like you're designing something with a 816 with a 14 megahertz processor, but somebody comes along and says, hey, you need to have a data set port on your computer. It's like, you got to be kidding me, right? And then you almost got people menacing you if you don't put it in. It's like, no, I'm not going to put like that stuff in. Well, what's the point, right? So anyway, this is really the hard part for me. Was really, okay, I need to deal with that stuff, and I was not ready to deal with it, and that was really difficult. And but if you do manage, then you come to the point where, okay, I got something that works, and I need to mass produce it. And this is I think one of the example where, and David Murray with the X16 came to the same realization, because all his team the technical team went through the same process I'm just explaining to you. So all these choices, all the debugging phase, the design phase is the easy part. And then you come and say, okay, I need to produce it. What am I going to do? So China is cheap, but in order to get stuff done in China, you need to ship anything that China doesn't have. So if you have FPGAs, you need to ship your FPGAs to them, because you rarely can find the newest model they don't have access to. So you need to pay the duties to get your stuff in there. You need to have a lot of quantity to make it worthwhile. And then they're going to ship it back. You'll have to finish them. You'll probably have to finish them with some true old stuff if you don't get everything there. It's a nightmare. And if you have a lot of volumes, it's something that you can manage. I mean, if it was like if I had volume like the Atari VCS, the new one, it would not be difficult. I can deal with production with $1 million in my bank account. But when you have buy 40, 50, 60, it's very difficult, because it's very expensive to ship your stuff over there. The overall CM is definitely cheaper than in Canada, for example, the United States, but the overhead is still very expensive. You need to pay duty, shipping, bring it back. They have toolings and everything. Here, locally, it costs really an arm and a leg and an arm and a leg and an arm and a leg. It's very expensive. It became very expensive because, it's so niche now. So for me, early on, where I used to work, I had access to the surface mount machine, the picture I put on. So that was a cheap one, and it did well. But then I left the company. I didn't have access. I still don't have access. So I built everything by hand, because it's more economical to do it this way. Because, for example, I could ask GLC-PCB to do it, but GLC-PCB doesn't do only one side. It's like so okay, if it's going to be half fabricated, then might as well do it all. So this is another hassle you have to deal with. So fabrication, buy all the parts, have to buy reels, buy more quantity that you really need, hoping that you're going to sell more, because you cannot buy just 10 FPGA. You need to buy more to make it worthwhile for the shipping, duties, and everything when you're buying from China. So China is great to have a lot of parts, but China is also a headache because you have to pay more. Well, it's not more, but you need to pay extra fees for duties and taxes and shipping and everything. But the other side of the coin, which is interesting, is that if it's small quantity, then you don't usually pay duties and everything, because it comes to normal mail, and the people at the border don't care. So that's the positive side of this. So this is the only electronic parts. Now you have to deal with the 3D printed parts. So you have to deal with printing the parts. So if you have 30 orders, you have 5 parts. I'm going to show you the A2560K. There's like 5, 6, 7 parts, different parts in the system that are 3D printed. That's a lot of 3D printed. 3D printed third party, same thing. It's more costly, it costs more. I was trying to sell the product less back in the days. Now I really don't care. I think people interested in the product will buy it no matter what. So I tend to sell a little bit more than before. Some people complain, but I guess if they're not willing to invest in the whole process or product, then there's no point for it to be cheaper. And these things are literally built by hand, one by one. So might as well just make it worthwhile for me. So mass production is it's like trouble. And then assembly, when you get your assembly, if you get it somewhere else, if you do it yourself, you need to test, spend hours testing my stuff, make sure it's working. You don't want to get it to be out in the wild and not work. This is one of those things. You cannot let something go without testing it all, and that takes a lot of time. So you're very far away from the fun parts of designing at that point. So that's really a pain in the butt. So the assembly, the final assembly, to put it together, if your 3D print failed and stuff like this is really like a lot of time spent. Testing, same thing. A lot of time is spent, and it's a lot of work. So I wish I would have and it's weird because in my case, sell very small numbers of units. And it's the reason I decided to sell very niche, definitely more expensive stuff. If I do less, then at least it's worthwhile doing it. But early on the FMX, I spent hours on end. I was spending at least 5 to 10 hours to assemble, to put it together, to test it, to make sure it was perfect per unit. So 700 hours I spent in average to get these things out. because I'm still alone to do it. And back in the day I was working, so it was really just using the time I had left. So yeah, so again, my personal biggest issue is still because I'm working on my own and I'm doing everything myself. And that's why at some point you need to go back and do another sanity check and say, hey, is it worthwhile? You managed to create a product, you designed it, you assembled it, you tested it, you shipped it, people are happy, because that's really the point. It's not even about money. I'm not into this to make money. I'm not going to get rich with this. It's really for the fun of doing it, but it's really for people to, the reward is really to see people enjoying it and coming back to me and say, hey, wow, I have so much fun, because it's really rewarding to create stuff and see the results and see a sprite on the screen appear, and then you get animation going and stuff, and then you end up having a game or something. So this is the rewarding parts, and that's why I'm still doing it. So yeah, so when you're at the end, you ask the question is, was it worth it? It's a great question. But wait, was it worth it? It's a great question, but what? Hold on, I need to ship it? I'm talking about all these painful steps after you design, because if you're a designer, you tend to love to design parts, right? So that's the funny part. Nobody bugs you. You do what you want. You enjoy it. You create your thing. It works. You finalize it. You make it work. You want to sell it. Then you start getting into this nightmarish fabrication, buying, so on and so forth. But then when it's finished, you finally get it. It's in the box. You have to ship the damn thing. And then what? They charge you $20 more to get a tracking? So you got to be freaking kidding me, right? That's the way it is. It's so weird. So I'm going to ship something in US. It's going to be shipping of FMX in US was $20 to ship with a tracking was 40 something dollars. It was crazy. Europe, it costs you another alarm, and then you don't have any arms, any legs at that point, but you still need to find some to pay for the shipping. So even at the beginning, I was selling everything free shipping. That was a mistake. But anyway, shipping is another hassle in the process of getting your product in people's hand. So, and again, I'm repeating myself, I know, but I'm not big in for a lot of, and it's a bit of a problem. But anyway, I'm trying to enjoy it as much as I can. So yeah, shipping, duty, everything is a nightmare, but you deal with it. And finally, you end up in the end, the inevitable truth about what you're creating, sharing your passion. There's a lot of pain involved, like I explained. You get through this and you make mistakes and you fix them, and there's always the pressure to ship stuff from the moment you start talking about, oh, I'm ready to sell it, or you pre-sell it. And that's one of the difference with the A2560K that I'm about to talk about very soon that I did differently. I didn't talk about it at first. I just designed it. I created it to a certain point, and then I start talking about it, which was really different. It was definitely better. And this is something I don't know why I kept doing, just talking about my stuff, showing CGI models before it actually exists, and it's like this thing I'd like to inflict pain to myself and just put more pressure on myself. Any people that are pleasing people knows that if you're trying to please somebody and you put pressure on yourself, it's just going to destroy you. That's one of the reasons back in it was June 2020, I kind of made this video about like giving up and everything, which in reality, I never really gave up. It was just like a frustration video because people were complaining. It's like, why are you complaining? And some people are just complaining about details, but it just runs you down to hear people say, oh, I wish there was this, I wish there was that. Dude, do you have any idea what it takes to create these things? So this is really, the process of creating something from scratch and to bring it into market. Then you have to deal with all these things. And now it's even worse because of the parts availability and all these crazy things in the world. And am I going to get my parts? And the funny parts is that I don't have too much problem with availability. FPGA is a problem. It's not a total, because I use older parts. Retro computing is about old stuff. So finding old stuff is easy. Aside of the FPGA, but they're stock. It's just that they're selling it more. And sometimes they sell you recycled parts. I don't have any problem with recycled parts either, because, you know, if I can recycle them and they work, I don't care. It's not like I'm going to create a weapon with this and they need to work in the military. So in that case, it's fine. So overall, if I manage to buy more, if I could buy more, then I could stock and I would be fine. So it's not even an issue. But, you know, you still need to find all these different parts and stock them. And I don't have the money to do this. So again, my biggest problem is that I don't have enough volume, but I'm serving a very niche market. But anyway, was it worth it for me? Most of the time, yes. It's really can be really rewarding. I think now it's more rewarding because I think the community is bigger, it's more involved. The community that was created around the Foenix is very, very strong, very solid, very dedicated, and I love them to death. They're really, really into the whole Foenix line products, and it's great. And I hope more people will join, because we're not about bullshit. I'm very transparent about what we're doing. I'm keeping people up to date. It's really important for me to know what's going on and for people to know what's going on. Super, super important. So I might not be as famous or important as others, but, you know, I think what we have is very, very interesting. And I think they're going to love me even more now, because I'm going to talk about the thing they've been waiting for a long time. So this is it for the first part. I think I've just hit the 1 hour time. I'm wondering is there anybody who would like to ask questions about what I've just talked about? And if there's none, then I'm going to move on to the other part.
All right. Any questions for Stefany about part 1? Yes, I have a question. So he's curious about I/O voltages and so forth.
About I/O voltages, about what?
Stefany, can you hear?
Yes.
Okay, so one of the challenges I see when you're trying to do retro stuff is everything wants to be 5 volts from the 70s and 80s and so forth, and no modern part seems to be able to do that or want to do that. It looks like you're using 3.3 or something like that. How have you dealt with I/O voltage issues?
Well, it's an issue. It's been an issue for the audio chips a lot. I mean, most of the CPUs I've used, like, for example, the 68,000, it's an SEC. It says 5 volt and 3 volts. These 816, the 65C816 is the same thing, 3 and 5 volts. The biggest challenges will be with the 68,000, the 68030, these bigger guy, because even the 4060Xs was in 3.3 volts. So how I did deal with it was, for example, the audio chips at some point, it required a lot of IOs from the FPGA. I started using these logic chip. They were serial to parallel chips, but they handled different power supplies for the serial port and parallel port, which was absolutely amazing because these parts were perfect. So I think they're the 595, but they have a class where you have dual power supply, which was absolutely amazing. So that fixed a lot of problems. There's also the TI, the level translator, without having to tell him which side you need to go, which direction it needs to go. I would say that it's a hit and miss with these guys. Sometimes they work very well. Sometimes they start oscillating. It's a pain in the butt. I've not been able to define or know exactly what is making them oscillate at some point. And to be honest, I'm still on the fence about how I'm going to go about dealing with the 68030, because even in the A2560K, it's a 68040V, which is a 3.3 volt version. I'm trying to stay away as much as possible about translators. Ideally, I guess I would have to use normal translators with strobes that tells the direction. So what I might end up doing is maybe create a prototype boards with a 6830, 68EC or 30 or something like this with translator like the TI, but even the TI parts right now are difficult to find. So to see how they behave in high speed and everything, because I use them for joystick, for example, and they start oscillating. That was crap. I had to remove them. So that's how I've been dealing with this. But it's not been hitting me hard so far. It's not been major components. It's kind of sad because it does increase the cost of everything because you need to translate everything. But yeah, I'll probably have to do some tests to really see with the 68,000 family how it's going to behave. So that's how I managed it so far. Any other questions?
Looks like no other questions. All right, so you ready to move on to part 2?
Yes, part 2. Ta-da-da!
All right, wonderful.
Yes. Okay, everybody's ready. Everybody's waiting.
I'm ready.
Okay, you are ready, huh? Okay, so before I do my showdown on this one, just a little bit of backstory. So the idea of the A2560K, aside of the fact that it just ended up being, I needed this board I talked about before to do the development, the base development for the Gen X. And fundamentally, the idea was to introduce DRAM to the system. And it's weird because I ended up realizing that moving to SDRAM, for example, for the video was a bad idea because there's a lot of overhead and I'm not going as fast to mitigate that overhead. And but when I decided to create that board, I said, okay, out of this, I'm going to create a product. And the A2560K was born, but it's been in the back of our heads, me and other member, the Alpha group, for a very long time. So we always talked about, hey, I'm going to get a keyboard version. Never happened. And actually 2 years ago, I got somebody to develop a keyboard PCB for the product. And only this year we actually, well, we had to revisit it and change it, but ended up being used. So it's been in the plan for a long time. The 68040 is, the whole system is really like something I wanted to do for myself as opposed to do it for others. And it's the most expensive one. I made sure to make it really fancy. So if anybody wants it, they'll pay for it because there's a lot of time involved to fabricate it. But I think people will like it and they might actually put the money in it because every time I say 68040, I see some grins in people's face and they start going crazy. And the keyboard is also an aspect of what they really are attached to. So without further ado, so I guess I'll show you the picture of it. So where is it? Oh, so there it is. So let me center the product. So there it is. So this is the A2560K. Let me shrink it a little bit. Do you see clearly? Okay. All right, so this is the A2560K. It's a 68040 base system. It comes with a 25 megahertz version. Although there is a 40 megahertz V version. Rochester Electronics sells them, but they're sold $300. So it's very possible that I might offer a more expensive version with a 40 megahertz. If I switch, I can show you the overall. And I'm going to go through the specification. Let me put you the pictures. I'm going to describe the thing. I just want to make sure that you see. So the system specification is a 68040, like I said. In the system, on the board, there's 4 megabytes of SRAM, fast RAM. There's 64 megabytes of SDRAM. That is separated, so you can do DMA, SDMA stuff within the system. There's 4 megs of flash. I forgot to put it. There's VK3, the new incarnation of the next generation of the VK series, which basically has 2 separate buffers, so I will be able to do more. There's also a dual, you can see it on the picture at the top. There's a dual Ddi output, so 2 screens. You can do bitmaps, sprites, tiles. There will be the Prism algorithm implemented in the hardware. It's not done yet. There's multiple resolution you can use. So very low resolution, 320 by 200 to 1024 by 768. So this is really what, and VDMA in there, and there's a lot of stuff. So I couldn't list everything. Let me move the picture again. So in terms of audio, there's still a lot of stuff. So there's 2 empty SID sockets. I'll show you the PCB later. There's one real 7649, which is the sound chips from TI that has been used with the 2612. The machine comes with 1 real chips, 2 FPGA version of it, 2 Gideon SIDs inside. You can configure in 3D and mono. So ultimately, you could have 4 SIDs in the system, 2 real 2612. I think there's an FPGA version as well. There's a real 2151 as well. The MIDI in, MIDI out, RCA in. You can simple out, and you can simple in. So you can do captures. You have integrated speakers. I'm going to show you the pictures. So underneath the unit, so there is the, hold on. So under the unit, you have 2 speakers, and the little knobs in the front is the volume that you can adjust. On top of that, you have the floppy drive for good measure, the SD card interface, the 2.5 inch drive that you could put inside, dual serial port, single parallel port, do good old stuff. And finally, you have all the joystick, 2 DB9 Atari style that you could put a normal joystick, but you can also use the adapter I created for the U versions that allows you to plug for SNES or NES joypad. So ultimately, you could have 2 of them. So you could have 8 of each if you wanted to. You have also, there's relays on the board that allows you to switch to analog modes. You have the keyboards, and the keyboards comes with RGB lighting, although the programming for this is not done yet. So yeah, it's in terms of compatibility. Well, compatibility, you have to see these computers have sandboxes. So the goal is really for you to start from scratch. We are developing a kernel in C that will be used across all the different platforms, which will be standardized. But basically, it's really the minimum. You load, you execute. There's a debug mode in the back that you can plug, download your code directly in the memory and execute it. So all the Phoenix's products have that. So if I show you the next picture, so this is the board inside. So that was ultimately that was my stomach is growling. So this is the main board inside. So you can see the 2 sockets for the SIS at the bottom right. You have the sockets for the 7680-489, the OPN2 and OPM. The MIDI, you have a Super IO in there. So there's a lot of legacy. So the overall idea, like I said, is to have different processors, same hardware. It just being brought from one product to the other, which is a reason why I can produce stuff so quickly from one to the other, which some people think I'm not focused, but I'm really focused on what I'm doing. I'm just like really creating a lot of new products because I'm trying to get these niche group of people that would like to design on something else in the 6502. And no offense to the 6502 community. So this is the board I've been developing too. And what I did is I created these small modules, maybe you can see at the bottom of the picture, which has a 68,000. And this is how I start developing the back end of the FPGA for the 68,000 that then I translated to the U. And ultimately, this is a comparison I'm going to show you. So this is the comparison between the A600 and the 2560K in terms of size. So it's a bit longer. It's about the same height, although my front end of the keyboard is definitely more bulky. It's a little bit more like a bread bin, a C64 bread bin. People buying it can choose the switch they want. There's not that many options, but bottom line, you can choose the switches you want. It's in pre-sales. The board have been, like I said, there's still a little bit of work, but it should ship for the next 2-3 weeks. So I'm very close to be finished. And what else? Did I create something else? Yeah. So this is what the A2560K. So this is the roadmap for what's coming. So in October, the C256 Foenix U is shipping. The A2560K 50U will be shipping as well. So these are level entry products. For now, I'm going to stick with these 2, but I was thinking about bringing others, which might be a little bit bigger with bigger processor later. The A2560K will be the next in line, and then the Gen X's and the A2560X. And then later we'll see. And then there are different modules I want to bring in, but these are the standard. Basically it's going to be 68,000, 68 EC030, the EC040. Basically the only one for now, at least for a while, to have a 6840 with the MMU, because everybody's like, oh, I would like to install Linux on it. is the 2560K. So they'll have to pay a premium for it. Because early on, I wanted to stick with non-MMU oriented machine to get people to stay grounded for a while. Maybe later we'll do it's planned to do the 68040 for the Gen X version, and maybe the Mips. There's definitely enough pins because it's multiplexed. I could do the Mips later for fun. So that would be one of those fun projects just for fun and to create modules with it and stick it in there and try to make it work. So this is what the 2560X is, and I'm hopefully people will find it interesting, at least attractive. And that's it. This is the big thing. I don't know. I'm going to hear about my community real soon about it. It's like, so is there any question about it? I can show you live, actually.
All right. Any questions? Yes.
So this is it.
Do you want to come up?
Yeah. Well, first, just can you hear me okay?
Yep.
Congratulations. It looks amazing. I have two questions. One, you mentioned at the beginning of this something more about Mips and SGI and your thoughts on all of that. I'm an SGI dork, so I would love to hear you expand on that. And the other question is, what brought you to the choice of 2 DVI outputs? There's so many options, and that seems like an interesting one, so I'd love to hear about that. Thank you.
I'm not sure about the first question, but I will answer the second question first. The second question is that along the way, okay, so when people starting to develop with the Foenix, the normal Foenix, people did a lot of debugging. When you start a new computer, obviously you need to develop a lot of things. You need to develop a lot of stuff. And for example, one of the person in the community started doing his own GUI interface. Mike Bush started doing this, and you're developing a GUI, you need to do a lot of debugs, and he was using the CL port. And at some point the idea was, okay, I wanted to get people to maybe look into developing some expansion cards for the system. Although in the 2560K, there's no expansions. But so I figured that with a simple FPGA that I had some in my hand that I was not using, I could develop a simple expansion card. And that would be simply a text, a second display, just text. Okay, simple video memory just for stuff. No bitmap, nothing like this, to use as a debugging tool. And when I got to do the Gen X and everything, I was like, okay, I have extra resources in the FPGA. I could re-implement it because it's a great way to have a second text mode. It's a great thing to have because you don't waste time waiting for the serial port and you can have your thing live. And then thinking more about it, sometimes I wish I would not had stuff like this because it's very over designing to a certain degree. But at some point you can also see the positive side that it gives an edge to a certain degree because you have the possibility, because in the Gen X's and the 2560K, because they both going to use the VK3 implementation, I will probably do a little bit more with the text mode, which means that you could actually do a little bit of graphics. So one could create like an RPG game, for example. You could have your text on one side and your graphic on the other. So you won't have two things that are exactly the same. But yeah, it's really one of those things I created. I thought this is great to have a video. And even for me to do some development, I think it's very handy to have a second video output. And it's kind of trendy nowadays to have two monitors. So I figured, but it came to a surprise when I realized, when I asked as a small survey on the community to see if most people would use it, and it turned out that not everybody would use it automatically. So we had to change our strategy a little bit about how we're going to use it in terms of kernel driving and everything. So it's there. It's not that much of a big deal. It does take some IOs from the FPGA, but I thought it's a great to have. So do you mind repeating the first question?
Well, I guess so. I think you answered a more interesting thing than what I was asking initially about the 2 DVI outputs. Is it something about the VCF3 that makes it easier to do digital output instead of, because there's no analog video output, or did I miss something? Is there analog video output on that?
You mean VGA analog?
Yeah.
Yeah, you do have a VGA analog.
Oh, okay.
I mean, the data is coming in the DAC, the video DAC, and the DAC does both.
I see. And
so you could literally have a monitor, CRT monitors on both if you wanted to.
Gotcha. Okay, I guess I just missed the ports. That's awesome. Cool.
I didn't mention it, but it's like inferred, but well, it shouldn't be inferred. For me, it is, but it's not. Sorry.
And the other thing, you were mentioning a Mips version, or
yes.
And when I maybe I misunderstood, but early on in the presentation you were talking about silicon graphics.
Yes.
So is that because what's involved in bringing Mips implementation and what about silicon graphics? What in the community? What's the talk been about that you've been interested in?
Like I said, obviously the first step for me is to create the machine, the Gen X, and with the FPGA in place, there's only a certain number of pins I can use. And for example, and that's kind of limiting to the 32-bit processors still. And the idea is really to design all these different processors in. And so the Mips came a little bit afterward because I I knew about the Mips a long time ago, but it was been so long. I didn't remember that the Mips and it's an architecture as a multiplexed bus, right? So 32-bit of one, and you do a multiple. I have enough. It has a 64-bit wide bus, but you do multiplexing with the address and data and everything, which is something I could support with the machine. So the idea to support the Mips and the fact that I've been heavily inspired by the fact that, with the SGI is a bit two different things in reality. The whole system is supposed to be a sandbox. You could probably bring in an OS from the SGI world and try to port it. I don't know. There's two different things for me. There's the physicality and the design of the products itself, which is really inspired. And the fact that I'm probably the only one doing, new retro system based or close to what the bigger system were at the time. Mips is really just for fun. I don't know if people would be interested. It's like the 65816 and the 6502. I know Motorola is the same. I think Motorola will get a lot of people on board, but I'm not sure if Mips would. But it was just for fun. From the moment the back end of the machine works, you can put any modules, and that's why I also talked about doing RISC-V and stuff like this. All the fancy stuff, because at the end it's just the modules you can design, put it in, and the Mips allows me to do this. But for example, the PowerPC would not allow me to do it because there are two 64-bit buses, or 32-bit buses and 64-bit wide data that I couldn't do it because I don't have any pins. So I don't know if it answers your questions.
Yeah, answered your question.
Good.
Answered his questions. We have another question. You want to come up, please?
Can you hear me okay? Hello? Can you hear me all right?
Oh yeah. If I don't hear, I'll let you know.
Yeah, first thing is congratulations. The type of work you do is amazing. From soldering or at least baking all the parts on to all the 3D design, it's something else, quite an accomplishment. I have two quick questions. One of them is, do you have any concerns about heat dissipation? I'm not sure if FPGA and the big 68K running on there, and maybe some power regulators cause any issues, or you got that all taken care of. My second question is, from an FPGA perspective, is that the same component that you run on the U, or is that a bigger one because you need to do a lot more with it?
Again, I'm going to answer the second question first. Yeah. So the FPGA, the problem is that in terms of resources, I think the size would be a limit. I came up with the problem of IOs mostly with the new generation of machine, including the 2560K, is definitely a bigger part because of the IOs. So the U's are using a 40,000 gates. I use about 65% of it with everything included and the floating point unit. And this is something I forgot to mention. There's a big floating point unit in the FPGA. And then when I came to the 2560 with the dual display, doesn't take a lot of pins, but does take a little bit more pins to support 2 DACs. plus the SD-RAM, plus the dual channel video system with the memory, although it's used to be, you know, SD-RAM, now it's going to be SRAM back again. I was kind of limited, and the 68,000 the 040 takes a lot of pins, more pins than it takes a lot of pins. So I was kind of forced to use the bigger parts because in Intel lineup, there's few parts that has like 500 and something IOs, and I'm using like 90%, 95% of them. So this is really what justified the fact that I was using a bigger parts. The parts, if I was buying those parts here, it would cost me an arm and a leg, like $300-400. In China, they're a lot cheaper. There might be reused parts, reballed parts, but I would rather use a bigger parts, which is 115,000 gates, although it's not even close. It's half what the Mega 65 has. But these guys seems to be connected. But for me, it's a lot. So I have a lot of room to implement a lot of different things, although I don't want to spend like my time to implement more. So this is really the answer to the first question. The second question. The first question is about the power dissipation. The 6840 in the V25 doesn't consume a lot, although in the next revision of the board where I need to make those small modifications, I will probably include possibly a fan connector to put a fan on the 40 megahertz version. It's a couple of, I think it's a watt or something, the 25, so it's not a big deal. Although I have to be honest, I'm going to be changing the power supply just to be on the safe side of things. The enclosure has vents and everything, so I might put a fan possibly, and the Super IO happens to have a fan controller on it, so I'm going to probably use it just to be, but I don't think the FPGA itself it's barely warm. You're not going to burn yourself on it. You don't need a heatsink for it. It's, I'm just, only the Viki engine runs at 100 and 200 megahertz, and it's mostly for the back end to get the video out. So it's not drawing a ton of current either. The rest is very slow. The 20 megahertz, 25 megahertz bus, even 40 megahertz bus is still pretty slow. So I don't think I'm going to have much problem with dissipation at this point, but I might be wrong. I did have some hubris in the past, and it came back to bite me in the ass. So right now it seems to be okay, at least for the 25 anyway.
Are there any more questions? Nope. It looks like last call for questions. Looks like that's it. No more questions.
All right. Well,
thank you, Stefany, for coming. And now it's like to see that the that new system is out. I don't know if you answered this question. What was I was noticing the naming scheme sort of changed. 256 and 256.0, the 256.0K. Did you explain about the different naming scheme before?
Well, the naming scheme I know it's basic, but early on in the idea of the C256 Foenix was, with the David Murray thing was really, okay, what would be, it was supposed to be the idea behind it, or the philosophy behind it was, it was supposed to be like a virtual successor to the 128. So 256 was meaningful. And since everything is 1 byte in terms of colors right now, everything is 1 byte per pixel. So only 256 colors, but there's 8 lookup tables you can choose from. And anyway, it gives you a lot more colors you want, but out of 24 bits. But so the idea of the C256 was based on, that product I'm going to design, because my rule was, I set myself some rules because I didn't want to do like the Mega 65, and I'm not complaining, or I'm not, dishing, saying bad things about them. It's just that I didn't want to end up having just plopping an FPGA on the side of the board. For me, was like, there was no challenge. There was no real design idea. It needed to be more. So my idea was, okay, let's design this thing as close to what it would have been in 1990s. Of course, it was very difficult to really go full flange with this, because it just got you in problems getting parts and through holes and stuff like this. So I kind of curbed my own, I went around my own rules and tried to make it look and feel as much as possible as the 90s. So that's what I started off, and I keep trying to go that way. It's just that halfway through, the Phoenix name was the fact that the lost brother that never came, and then it just came out of nowhere. So, and I was sure that anybody else doing the project for David would come up with C256. So I kind of, okay, I need to put another name next. So if somebody come up with the C256, I have something else to differentiate myself. The Phoenix was really, okay, it's going to rise, and the new brother, whatever. But it only lasted a while. The idea lasted a while because I realized that with the Commodore 64, the Commodore community in general, you cannot play with this. It's like a legacy. You cannot assume anything, propose anything. I'm sorry, that's the way it is. It's like a cult, right? And you cannot play with the cult. And I realized that at some point I kind of distanced myself, and I was not going to be compatible with anything that existed before. Like the Amiga 65 is compatible with C64 and so on and so forth. They had their plan, it was great. But my plan was just not to be compatible because I wanted to create a sandbox. So no way I was going to do this. So that's the backstory for the C256 Phoenix naming. But the C256 Phoenix ended up being very close to what an Amiga was. And for me, an Amiga is something I never got. And it's something I was very inspired from. So when I came up with the 68,000, then the A came from the Amiga. So the association with C for Commodore, A with the Amiga. And then I thought that, okay, if I add a new zero, it's like you're going from you're going to a different exponent, for example. You're just increasing the number, 32 bits, 62 bits. So that was the idea between. So that's the reason I came up with the A2560. So it's Amiga type machine, if you will. And I wanted to keep the 256 still. The letter afterwards were really like, okay, the use for, the K was the first one because it was the keyboard version, and the X was, so that's really the scheming. So there's really nothing special aside of, okay, I wanted to keep these names, although some people complain about the fact that it could have been a little bit more fancier than it is. But for now, this is where we're going with this. So this is the backstory of the Amiga, or the A in front of the 2560K.
Since there are no questions, thank you, Stefany. Great talk. I really hope to see you in person next year in April at our next show. Yes. And you'll have two, because you have two other talks that we had, discussed a while ago. You can do those two other ones. It'll be great. So I appreciate it. Well,
thank you for inviting me again. Thank you, Jeffrey, Corey, everybody in the background, if they're still there. Thank you very much for listening. It was great. Thank you for the opportunity. All right. Thanks, guys.